Here we're going to look at a couple of examples on how to factor trinomials using either the essentially reverse FOIL method, or by using things like the AC, or as it's also known as the bottoms-up method. Now there are many ways in order to factor a trinomial, but before you even get started, you have to recognize the parts of the trinomial that are going to help you with your factoring. So trinomials are equations that have three terms, and within your trinomial, okay, you have clues that are going to help get you from the trinomial down to its factored parts. And those clues are going to come from the signs, okay, the signs between your B term and your C term. So first and foremost, let's go ahead and start with your C term. So when we're talking about our C term here, we are talking that this sign tells you what you are multiplying. So your two terms must multiply to give you the C term, and so the sign is very important. When we're talking about the middle sign, or the sign of your B term, this one here tells you that you are going to add or subtract. Okay, or essentially what we're talking about is that you have to add to this term. Now with that, there's a few things that occurs. First, we have sign options. So when we're looking at that, we have our sign options. So here we have that we can have positive times positive gives you a positive result. So when we're looking for your factor here, we're talking about my two factors, so we want to get this the term there. Well, that same thing says we have negative times negative. Well, that also gives you a positive result. Last, we have positive times negative, which gives you a negative result. So what we have is we actually have three sign options. So this back term here is going to tell you which part of your sign options you're going to be. Okay, so you're either going to be here in your positive or here in your negative. Okay. Now the middle term here is going to tell you which you must use. Okay, so again, your back term here is going to tell you the possible choices of sign combinations. Okay, so that's what that one's telling you. Whereas your add and subtract one is going to tell you which choice must be used. Okay, so that's kind of the clues that you have. Now with that, there's a little phrase that I always like to stick to, and that phrase says this: if your B term is positive, then the bigger factor is positive. However, if your B term is negative, then the bigger factor is negative. Okay, so you want to pay very close attention, and that is going to help you determine the signs of the individual factors based on the ideas of the whole. Okay, so that's essentially, in a nutshell, what you need to know about a trinomial polynomial. And the clues that you have to use in order to factor it down into its pieces. So what we're going to do is we are going to look specifically at some examples here where we have to factor. So as a reminder, we have these options. And so here, just like before, we have our signs. And so first and foremost, we know that this back term here is going to tell you which possible options to use. So here we've got the negative. So in this case, if you look, I have positive, positive, negative. I only actually have one negative choice. So in this case, because I only have one negative choice, I don't need to worry about the middle sign telling me an options to use. Instead, the middle sign here, this one, since it's negative, tells me that the bigger factor is negative. Okay. Now the only reason why I can skip to this right away is purely because this back term is negative, which means I have one positive and one negative as my factors. So once I figure all of that out, now I have to look at it. And so in this case, my back term is 27. So in other words, what I need to do is I need to find factors of 27 that add to negative 6. So if I look at 27, I have negative 27 is my term. My factors of 27 are 1 and 27. I have 3 and 9. And if I'm looking here, I need a negative 6, and so that's going to tell me that I have to have a positive 3 and a negative 9. Okay. I also know for a fact that this first one is not going to work because I'm not going to get my negative 6. So I have my two factors here. So then all I have to do is I just simply have to use the form x plus or minus c. Okay. Now in this form, it's really important to note that this c term here stands for the factor, and the sign right here is going to be obviously the sign of the factor. So here I'm going to create, so I have a positive 3, so this is going to be x plus 3, and I have a negative 9, so x minus 9. Now to check myself to see if I got everything right, I could simply multiply these back together, and when you do so, you could come up with what you started with. Okay? So in a nutshell, that is what we are doing. So let's go ahead and do it again. Notice again for this one, my a term is 1, and so I can go ahead and use this factor method. So just like before, we can go ahead and take a look. This back sign here, this tells your possible options. And so here I have positive, so my possible options are going to be positive times positive gives me positive, or negative times negative gives me positive. And then this term right here, this tells which option to use. So here this is positive, so that tells me that I'm going to be using my positive times positive option. Now since both of those factors are the same size or sign, I don't have to worry about bigger or smaller factors. I can just go ahead and find my factors. So here again I want to find the factors of 12 that add to a positive 7. So here I've got my factors of 12. So I've got 1 and 12, I've got 2 and 6, I have 3 and 4. So I want to look at which combination of these is going to give me 7, and so I'm looking at a positive 3 and a positive 4. And so again, I want to use that form. So here I'm going to have x plus 3 times x plus 4. Alright, let's go ahead and take things up a little bit. Now, the first thing I want to notice is that my first term here, so this term, okay, is my a term, which is greater than 1. So in this case, we want to use the bottoms up method. Now I say that because to me using the idea of the bottoms up method is a lot easier than trying to use grouping or any of the others. So I'm going to show you how this method works. So the bottoms up method says that we are going to take a times c. So the first thing we're going to do is we're going to do a times c. So that's going to be 6 times 5. Both are positive. Remember, your signs are incredibly important. And so here this gives you a positive 30. The second step that I have to do is I need to find your factors that add to the b term. So I'm going to look at my factors of 30 here. So I have 1 and 30, I have 2 and 15, I have 3 and 10, I have 5 and 6. So I need to know which combination of these is going to add to 17. So in this case, remember the back term is positive, the middle term is positive, so I need to know my options. So just like before, when we're looking at this middle term here, this tells you the option to use, whereas this back term right here tells the possible options. To choose from. So those options, because this is positive, are going to be positive times positive or negative times negative. And just like before, since my middle term is positive, I'm using the positive positive option. So you always want to make sure and kind of work yourself through those steps. They are going to help you in the long run. And so what that also means is that I need to add to 17. So I'm going to use positive 2 and positive 15. Okay. So these are going to be the factors that I pay attention to. Once you identify the factors, your third step is going to be your setup step. And what you want to set up is we are setting up x plus or minus your factor over the a term. So we are going to set this up for each of our factors. Okay. So the way that that works is we have x, my first factor is a positive 2, so this is going to be plus, and it's going to be 2 over 6. 2 is the factor, 6 is my a term. I then need to do it again. I have x, again this is plus, and it's going to be 15 over 6. Once you have it set up, the fourth step is you have to reduce the fractions, and you want to reduce them completely. So I have 2 over 6. Well, we know that can go ahead and reduce, so this is going to become x plus. It's going to reduce down to 1 over 3. And then I have 15 over 6. So 15 over 6 here is also going to reduce, and it's going to reduce to x plus 5 over 3. 5 over 2. And so here, once you have it reduced, now this is the bottoms up step. So the bottoms up step says you're going to take whatever is left here in the bottom, and we are going to shift it up to be the coefficient. So here, you're going to take whatever is left in the bottom and shift it up. And this is your bottoms up step. So what that means is that your factors are then going to become 3x plus 1 times 2x plus 5. And that is your factored form. Okay? So, bottoms up. Alright, let's go ahead and look at the next one. So here, first thing I want you to notice is that I have an x to the 4th. So what that automatically means here is that I have to pull out a greatest common factor. The other thing that I want to keep in mind is that I have this negative out in front that I want to make sure I remove. And so here, I already know for a fact that my greatest common factor is going to start with a negative number. So now I have to figure out the rest, and so I'm going to use a quick prime factorization to help me with that. So I have 6x to the 4th. My 6 can break down into 2 and 3. I know my x to the 4th can break down into x squared and x squared. I then have 14x to the 3rd. So here my 14 can become 2 and 7. My x to the 3rd becomes x and x squared. And then the last one that I have is I have a 12x squared. So let's put that right here. So I have a 12x squared. So here this can become a 3 and a 4. And my 4 breaks down to 2. I'm going to move this. Not quite so squished. Right here. I'm going to put it down here. So we know 12 can be 2 and 6, which can break into 2 and 3, and then this is x squared. So the first thing that I need to do is I need to identify my numbers that are common. So here I have a 2, I have a 2, and I have a 2. Once you identify the numbers in common, we need to look at the numbers left over. So what's left over is the 3, the 7, the 2, and the 3. And then, just like before, I need to now identify my variable. So I've got an x squared here, an x squared here, and an x squared here. Again, that leaves behind my x squared and my x. So if you look, my greatest common factor is going to be the 2 and x squared. So this is 2x squared. So the very first thing that I have to do is I have to pull that GCF out so that I can actually start working with my factors. Okay. So first and foremost, I'm going to pull it out. So this is going to be negative 2x squared. What's left behind is I can look. So for my first term here, I've got a 3. So this is going to be 3x squared. Then for my second term, I have a 7. Since I pulled the negative out, my sign here becomes positive. I have a 7 left over, so this is 7x. My back term becomes negative. I have 3 times 2, which is 6. And there's no variable because I pulled all of it out. Okay. So this is my actual new term that I have to work with. And now I need to see if I can factor any further. So the first thing that I want to do is I want to look to see if I can factor using bottoms up. Okay, so that's what I want to do. I'm testing it. So I'm going to ignore this little negative 2x squared, and I'm just going to focus here on my trinomial. So again, that first term is to do bottoms up, AC. In this case, it's going to be 3 times a negative 6, which is going to give you a negative 18. My second step is I need to find factors that add to a positive 7. So I want to look at factors of 18. So I have 1 and 18, I have 2 and 9, I have 3 and 6. So here I want to look, I need a positive 7. My back term is negative, my middle term is positive, so that means that my factors are going to have my bigger number positive, my smaller number negative. So that means these factors work, which is an automatic that you can factor this trinomial. Okay, since I found factors that'll do it, it means that we can do it. So in this case, we're going to go ahead and set up our factor. So here, this is going to become x. My first term is going to be minus, and it's going to be 2 over 3. My second term is going to be x. It's a positive, and this is going to be 9 over 3. So that's that third step. This is the setup step. That fourth step is where we're going to reduce. So here we end up with, I can't reduce my first term, so this is still going to be x minus 2 over 3. But my back term, 9 over 3, reduces, so this becomes x plus 3. The last step is I need to take my bottom term here and I need to flip it up. And so this is where we actually get our final factored result. And so here what we end up getting is we end up getting 3x minus 2 times x plus 3. However, we have a piece that we need to remember to use, and that is this piece right here. Okay, so we have to bring this one all the way down to where it belongs. And so here our actual result is going to have the negative 2x squared out in front with the factored form off to the back. Okay, and so that's how that one works. Alright, let's go ahead and take a look at another one. So again, first and foremost, we need to identify the important pieces that we have. And so here we have this first piece right here. So again, this tells the possible options to choose. And in this case, those options are going to be positive times positive is my positive, or negative times positive. Sorry, not positive. Negative times negative. Which gives you a positive. So negative times negative here. And then we have the back term. So this one right here tells which option to use. Okay, so that's what this is. Since this is negative, what that means is that we are going to use the negative option. So with that, I can then start. Since my first term has my a is greater than 1, we can go ahead and use that bottoms up method to make life easy. So here that bottoms up says we're going to do a times c. So this is going to be 2 times 4 which gives you 8. I need to find factors of 8 that add to -7. So I want factors that add to a -7. So I've got 1 and 8. I have 2 and 4. Since I want a -7, that tells me the bigger factor has to be negative. And so in this case, I'm going to have, both factors are negative. So here I've got negative, 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 negative. Now, if you take a look at these combinations, because of what we have, multiplying to the positive but adding to a negative, we already said that the option we had to use here was negative, negative. So that makes both of these negative, negative. So if I take a closer look, okay, factors -1, -8. Okay, if I actually take a look at that, my b term is supposed to equal the -7. Well, -1 plus a -8 does not give you a -7. So I know that those factors don't work. Then, if I take a look at my factors -2, -4, well, -2 plus a -4 again does not equal -7. So this is a very important thing to notice. Okay, so since none of the possible factors will work, the trinomial is not factorable. And so this right here is actually a really important thing to notice. So here, the only reason this is not factorable is because the only factors we have are -1, -8, and -2, -4. Since, according to my signs, I have to follow the rules. Again, the back term, or the back sign tells you the options to choose from. So here, my back sign is positive, so I have positive, positive, negative, negative. My middle sign tells me which option I have to use. It's negative, so I have to use negative, negative. That tells you the signs of your factors. When I add these factors together, I'm supposed to get -7, and in neither case does that happen. Okay, in my first case, -1 minus 8 is -9. And in my second, -2 minus 4 is a -6. Since neither of these factors work, I can't factor this. Okay, usually what that means is that if you were to solve this quadratic, you would come out with either a radical or an imaginary result. Okay, but for all intents and purposes of the factoring piece, it would be called not factorable. Alright, let's try one more here. Now notice these are some big numbers: 36, 114, 60. Whenever you have big numbers like that, the first thing that you should automatically try is to see if you can pull out a GCF. So if I look at 36, I know that I can break this down into, say, 3 and 12. My 12 can break down into 3 and 4. The 4 can break down into 2 and 2. With that, I also have 114. So if I look at 114, I can divide it by 2, gives me 2 and 57. 57 surprisingly breaks down into 3 and 19. And then I have 60. So 60 can break down into 3 and 20. 20 becomes 4 and 5. 4 becomes 2 and 2. So if I look at all of these, I can see right off the bat that I have a 3 that shows up in all of them, and I have a 2 that shows up in all of them. So in this case, what I actually have is I have that my greatest common factor is 3 times 2, which equals 6. Now with that, I also have pieces left over. So in this case, I have a 3 and a 2. In my middle case, I've got this 19. And in my last case, I've got a 5 and a 2. So what I have to do is I have to draw out my new factor. So here the 6 pulls out, and if I look, pull the 6 out, and what's left? 3 times 2, which is 6, and squared. My sign is negative. What's left? 19n. My sign is positive, and what's left? 10. Once you figure it out, now we need to go ahead and see if we can factor this again. So, identifying its pieces, what do we know? This back term is going to tell you that you have positive times positive, or negative times negative. This middle term here tells you which to use. So my middle term is negative, so we have to look at negative, negative. And then my front term here says that a is greater than 1, so I would recommend using bottoms up. Once you kind of have the groundwork, now again we can go in and get started. So bottoms up says we're going to take a times c. So this is going to be 6 times 10, which gives you 60. I then have to find factors that add to my middle term, which is negative 19. So I want to look at my factors of 60. I have 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5, 12, 6, and 10. So with that, I have to look at which combination is going to give me a negative 19, remembering that both factors have to be negative. So if we look, we have one factor that's going to work, negative 15 and negative 4. So this factor right here is what we're looking for. So with that, we can set everything up. So here we're going to set it up, which says I'm going to have x. My sign is negative, so minus, and this is going to be 4 over my a term is 6, and close it. I then have to do it again. X, again, my sign is negative. My factor is 15. My a term is 6. Now we need to reduce. So here 4 over 6 will reduce, so we're going to end up with x minus, and this is going to become 2 over 3, and x minus, and this is going to become 5 over 2. The last thing we have to do is take that bottom and shift it up. Again, take that bottom and shift it up. So here we have 3x minus 2 times 2x minus 5. The very last thing we need to remember is that we had this term out here, our GCF term. So this term here has to come over and drop down. So we need to have the 6 out in front. Okay? And that is how you factor completely. Alright, the last one I wanted to show you is this one here. So again, notice I have some fairly big numbers. So the first thing I want to do is I want to look and see if I can pull out a GCF. Notice I only have variables on the front two, so the only thing that I can factor down is my numbers. So I have 12. 12 is going to turn into, say, 4 times 3, which turns into 2 times 2. I then have 120. So my 120 here is going to factor down into 60 times 2. My 60 can become 2 and 30. My 30 can become 10 and 3. And of course 10 becomes 2 and 5. And then the last thing I have is 75. So 75 is going to factor down to 15 and 5. 15 becomes 5 and 3. So again, looking at all of these, I need to find the ones that are in common. And I have a 3 that shows up in all of them. And then I have leftover pieces. So here I've got 2 and 2. Under 75, I've got a 5 and 5. Under 120, I have a 5 and a 2. I also have another 2. And a final 2. So here, my GCF is going to be 3. So I need to pull that 3 out. So I'm going to pull the 3 out and look at what's left. Under my first term, I have 2 and 2, which is 4, so this is a 4n squared. My sign is positive. I have a 5 times 2, which is 10, times 2 times 2. So here this is going to give you a 40n. And then under my last, I have a positive, and I have 5 times 5, which is 25. So, in looking at this, again, I have my middle term. So, identifying its parts. This first term here tells you your options. Okay, so this tells the options. And in this case, you have positive times positive or negative times negative. The middle term here tells you which option to use. Because this term is positive, we have to use the positive term. And then this last term here says that a is greater than 1. So you would want to potentially use that bottoms up method. So again, we can look at a times c. So this is 4 times 25, which gives you 100. And now I want to find factors that add to positive 40. So here I'm looking at my factors of 100. So I have 1 and 100. I have 2 and 50. I have 4 and 25. I have 5 and 20. And I have 10 and 10. Now if I look at all of these factors, when I add them together I need to get 40. None of these work. So what that tells me is that since none of the factors work, you cannot factor beyond the GCF. So what does that mean? That means that my solution here is going to be 3 times 4n squared plus 40n plus 25. And that is the factored form. So what you need to notice out of this bottom one is whereas we cannot factor this trinomial, we were still able to pull a factor out, and therefore you need to. Okay, and so this would be the factored form to where we started with. So if you have any questions, please let me know. Otherwise, I do hope these examples helped you with your factoring that you have to do. And if not, please feel free to send me any troubling issues you may be having. I'd be more than happy to work them out. Otherwise, I look forward to seeing you next time.